Hello everyone. Today we will discuss about another one Darlington pair circuit. Here we are considering the current gain of the transistor of Q1 will be 30 and the Q2 will be 50 and base emitter voltage for each transistor will be 0.8 volt, and here we are going to find the base resistance value in such a way that we need to get the 3.3 volt across the collector to emitter of transistor Q2. So as we know that here we have to consider the collector gain of the transistor Q1 as beta 1 and Q2 as beta 2, which is equal to and 30 and 50. And similarly we have to consider the voltage across base to emitter of Q1 and Q2 will be VBE1 and VBE2, which is equal to 0.8 volt, and we need to find the, and we know that the voltage across the collector to emitter of the Q2 will be 3.3 volt, and here we are going to apply the supply voltage as 10 volt, and so that in this node we are getting the 10 volt. So this we can call it as VCE2. The VCE2 will be the 10 volt, and also we know that the collector to emitter voltage of transistor Q2 VCE2 will be equal to VC2 minus emitter voltage of transistor Q2, which is equal to VE2. And if we rearrange the term, the voltage VE2 is equal to VCE2 minus VCE of Q2. So which is equal to 10 volt minus 3.3 volt. And when we simplify this, we will get 6.7 volt. So that voltage at emitter terminal of the transistor Q2, that is VE2, is equal to 6.7 volt. From this we can find the emitter current across the transistor Q2. The emitter current across the transistor Q2 IE2 is given as VE2 divided by RE2, which is equal to 6.7 volt divided by 2.4 kilo ohm, which is equal to 2.8 milliamps. To find the base resistance of the transistor Q2, which is equal to RB1, we need to know about IB1, the base current of the transistor Q1, and also we have to know the voltage across the base terminal of the transistor Q1, which is equal to VB1, and we know that voltage across the base to emitter terminal of the Q1 and Q2 will be 0.8 voltage. So that if we apply the KVL rule across this loop, VB1 is equal to VBE1 plus VBE2 plus VE2, which is equal to 0.8 volt plus 0.8 volt plus 6.7 volt, which is equal to 8.3 volt. Therefore, voltage across the base terminal of the transistor Q1, this is VB1, is equal to 8.3 volt. In the Darlington pair circuit, The emitter current of the transistor Q2, that will be IE2 is equal to beta 1 plus 1 into beta 2 plus 1 into IB1, the current across the base terminal of the transistor Q1. Here IE2 is the current across the emitter terminal of the transistor Q2, and similarly IB1 is the current across the base terminal of the transistor Q1. The base current across the transistor Q1 is given as IB1 is equal to IE2 divided by, we know that the beta of transistor Q1 will be 30 and the Q2 will be 50, so that which is equal to 31 into 51, which is equal to 2.8 milliamps divided by 1581. When we simplify this, we will get 1.771 microamps, which is the current across the base terminal of the transistor Q1. So now we can easily find out the resistance across the base terminal of the Q1. So that the base resistance of Q1, which is RB1, can be given as 10 volt minus VB1 divided by IB1, which is equal to 10 volt minus 8.3 volt divided by 1.771 microamps. So when we simplify this, we will get 960 kilo ohm. So we can conclude that whenever the value of resistor R1 is 960 kilo ohm, we can get the output voltage as 3.3 volt across the collector to emitter terminal of the transistor Q2. Let us verify this in the circuit. So I am going to change the base resistance of the transistor Q1 will be 960 kilo ohm. Let us verify one by one. Initially we need to find the voltage across the emitter terminal of the transistor Q2, that is VE2 is equal to 6.7 volt, and current across the emitter terminal will be 2.8 milliamps, and voltage across the base terminal of the transistor Q1 will be 8.3 volt, and current across the base terminal of the transistor Q1 will be 1.78 microamps. When we consider the 960 kilo ohm resistance across the base terminal of the transistor Q1, we will get 3.3 volt across the collector to emitter terminal of the transistor Q2, so that our theoretical calculation and the stimulated value is approximately matching each other. Hope we are able to understand how to calculate the base resistance to get required output across the second transistor of the Darlington pair, and also we know that how to amplify the current in the Darlington pair. I request you to kindly subscribe and like the video. Thank you for the watching.